Now, this is a question from your previous exercise 1.3. Today we will study exercise number 1.4, but this is from first question from exercise 1.3. How to prove that under root 5 is irrational? I've just proved this out. You can go through this. Let under root 5 be a rational number. The rational number will be in A by B form, where A and B both are co-prime numbers. We can write it as under root 5 equals to B into A. Just B over here. Squaring both the sides, we get 5b square equals to a square. According to the theorem 1.3 of revisiting a rational number, if a square is divisible by 5, according to this, a square will be divisible by 5. Therefore, a will also be divisible by 5. As the square of a number is divisible by it, then the number itself is also divisible by that number. As a is divisible by 5, we can say that a equals to 5c. अगर ये 5 से divisible है तो 5c की फॉर्म में ही होगा ना. Again, putting this number in this equation, above equation, we get 5b square equals to 25c square. Further, we divide this 5 with 25c square, we get b square equals to 5c square. From this one, we get that b square is divisible by 5, hence b is also divisible by 5. Now, from this one and this one, both we get that a and b both are divisible by 5. But ये तो possible हो ही नहीं सकता. This is not possible as we have considered both a and b as co-prime numbers. This contradicts our assumption. Therefore, hence under root 5 is a irrational number. This is how you can prove this is a irrational number, and others also as irrational numbers. Now we'll come to the next exercise, that is exercise number 1.4, revisiting irrational number and their decimal expansion. Now, how you will get to know that any decimal number is irrational or not? I told you that in the last lesson only that 0.13375, this is terminating decimal number. Then this will never be irrational. This will be a rational number. Just take out the point, put the multiple of 10 according to the number of digits after decimal, and you will get your irrational number. Over here also it is irrational. This is also terminating decimal. Therefore, all these are terminating decimal numbers. Therefore, they are rational numbers. Now, what we get to know about rational numbers, again the same. If the rational number has a form of 2 and 3, this we will study in theorem. Let's say first theorem we will study, theorem number 1.5. Let x be a rational number whose decimal expansion terminates. Then x can be expressed in p by q form, where p and q are co-prime. The prime factorization of q is in form of 2 raised to power n. Again, this is wrong. The actual form is 2 raised to power n and 5 raised to power m. Means the factor of q should be in the form of 2n and 5n. This I told you before in last chapter also, that only if the prime factors of denominator have 2 and 5's factor, then it will be a terminating decimal number, else it will be a non-terminating decimal number. I'll explain it again in this also. Now coming to next one. Next equation is, let p and q be an irrational number such that prime factorization of q is in the form of this, where n and m are non-negative integers, then x is the decimal expansion which terminates. I'll explain all three theorems. The third equation is, let x be p by q, where p and q are co-prime, be the rational number such that prime factorization of q is not in the form of 2n and 5n, where n and m are non-negative integers, then x has a decimal expansion which is non-terminating, repeating, recurring decimal form. Okay, now it's time to study all these three theorems. Now we will study the three theorems of exercise number 1.4, revisiting rational numbers and their decimal expansion. How you get to know that the given number is irrational or rational? The decimal number, if it is, as I have told you, if it is terminating decimal number, it will always be a rational number. Like over here, all these numbers are terminating decimal numbers. So all of them will be rational number. Now how to convert them into rational form? This I have taught you in last lesson. Like taking out the decimal and putting the multiple of 10 in the denominator. Similarly, first theorem comes, let x be a rational number whose decimal expansion terminates. X एक ऐसा number है जिसका decimal number terminate करता है. Then x can be expressed in the form of p by q, where p and q are co-prime factors and q is in the form of this. This is actually 2 raised power n and 5 raised power n, not 2n and 5m, where n and m are non-positive, non-negative integers. I'll explain this theorem. Now, next theorem is, if x is a rational number in the form of p by q such that prime factorization q is not in the form of this, then the rational number will be having non-terminating decimal reoccurring number. Let me tell you all these three through this. Let us first consider p and q is a rational number where q is not equals to 0. First equation states that if it is a rational number, then q will be having a factor of 2 and 5 and could have many other factors also. Then the number will be terminating decimal number. Reverse of this is equation 2. If it is a decimal terminating number, if the decimal number is terminating number, then q will have a factor of 2 and 5m. The equation 3 states, if p and q are two rational numbers and q do not have a factors of, the denominator will not have a factors of 2 and 5, उसमें 2 और 5 के factors ही नहीं है, then it will be non-terminating repeating number. अभी भी वो non-terminating non-repeating नहीं हुआ, it will never be irrational, either it will be a terminating or non-terminating repeating. चाहे denominator में 2 और 5 के factors हों तो वो terminating, अगर नहीं हो तो वो non-terminating repeating. First वाले का, if I take an example, the example will be this 7 by 30, where 30 has a factor 2, 3 and 5. 2 and 5 are there, therefore it is a terminating number. And third वाले का example क्या ले सकते हैं? We can take example of 1 by 7. The 7 has only a factor of 7, therefore it will be a non-terminating repeating number. इसमें ना 2 and a 5 है. Other than this, if a number be like this, 7 upon 6, where 6 has a factor 2 and 3. Now it has a factor of 2 but not a factor of 5. Still it will be a rational number, but it will again be non-terminating repeating rational number. So all such numbers like 3 by 5, 4 by 5, 7 by 19, 8 by 19, they all will always be rational numbers. Either they will be terminating decimal or they will be non-terminating repeating decimal. Now, what kind of numbers will be irrational? If we divide a number and denominator be irrational, or a numerator be irrational and denominator be irrational by integer, such kind of numbers will be rational, rest of them will be always rational. Now how you will get to know that the number is after how many digits will repeat? First we will do the exercise number 1.4. Simply you can do this yourself without actually performing a long division. State whether the following rational numbers will have a terminating decimal expansion or non-terminating decimal expansion. Only decimal number will expand. Terminating, what is the condition of terminating decimal expansion and non-terminating? If the decimal, if the denominator will have a factor of 2 and 5, you just need to find the factor of 3, 1, 2, 5. If it has a factor of 2 and 5, then it will be a terminating decimal expansion. If it do not have a factors of 2 and 5, then it will be a non-terminating decimal expansion. Like in this case also it has a factor 8. Only 2 factors there, therefore it will be a terminating decimal expansion. इसमें 5 नहीं है, but इसमें कोई और भी नहीं है, so it will be a terminating decimal expansion. Over here you will get a factor of 5 and some other factor, therefore it will be a non-terminating decimal expansion with reoccurring numbers. It will have a factor 455 will have a factor 455 will have a factor 5 into 7 into 13. It has a factor of 5 but it do not have a factor of 2. Therefore it will have, and has many other factors too. Therefore it will be a non-terminating repeating decimal expansion. Next, if I take any other such number, it has both the factors, therefore it will be a terminating decimal. It also has both the factor terminating decimal expansion. Similarly, you can find others also. Now coming to second question, write down the decimal expansion of those rational number. In Subkey, you can write the decimal expansion also easily. You can convert this into decimal expansion by division method like this. The following real numbers have decimal expansions as given below. Decide whether they are rational or irrational, they are rational or not, and what you say about their prime factorization of cube denominator if they are rational. So this is terminating decimal number. So of course this is a rational number. And what about its denominator? Its denominator will have a factor of 2 and 5 because this is terminating decimal number. Now coming to this is non-terminating decimal number and it is not repeating. Therefore it is always a irrational number. And what about its denominator? Its denominator is not defined because it is irrational number. Now this one is terminating decimal repeating number. This one is terminating decimal repeating, non-terminating decimal repeating number. The third one is non-terminating decimal repeating number. So if it is non-terminating decimal repeating number, this we can also change it to rational form. And what about its cube? Its denominator will have a factor other than 2 and 5. This is the last one, and with this your chapter completes. I hope you will be able to do all the exercise and submit your work on time. Thank you. Stay home. Stay safe. Now let's do one of this extra question also from NCERT example. You have to do all the exercises of NCERT example also. In exercise number 1.4, let's do the question number 2. To prove that one and only one out of all n plus 2 and n plus 4 is divisible by 3 where n is any positive integer. Now we will do this extra question from NCERT example. Prove that one and only one out of n plus 2 and n plus 4 is divisible by 3 where n is any positive integer. How to solve such question? Let's see. First step is what we will do, we will write let n be any positive integer. N is any positive integer and b equals to 3 because we have to show that it is divisible by 3. Then according to Euclid division algorithm, n will be equals to 3q plus r, and where r will be greater than 0 and less than equals to 3. The value of r will be 0, 1, 2. Put the value in each equation. First equation will be n equals to 3q. Another will be n equals to 3q plus 1. Third will be n equals to 3q plus 2. Now taking this, each one of this with the given numbers, we have to find it for 3 terms. We have to find for 3 terms. One is for n, another is for n plus 2, third one is n plus 4. For these 3 terms we have to find this. Let's say first we are finding it for n. Number b n. If the number be n, then n will be equals to 3q, or n will be equals to, if I take over here 3q plus 1, if I take this one, or n will be equals to 3q plus 2. Out of this, only this one is divisible by 3. Only this can be divided by 3. You cannot divide this one with 3 because 1 is there. You cannot divide 3q because 2 is there. There isn't any common factor between them. Now we will check for next one. Second, number be n plus 2. If the number be n plus 2, then n plus 2 will be equals to, we will add 2 over here also, as we have added 2 onto this side. We will add 2 to this side, it will become 3q plus 2, or n plus 2 will be equals to, second one is this, it will be 3q plus 1 plus 2, or n plus 2 will be equals to, third one is this, it will become 3q 3q plus 2 plus 2. It becomes, it is not divisible by 3, because 3 and 2 will not have any common factor. It becomes 3q plus 3, that can be written as, we can take 3 common and it will be q plus 1. So this is divisible by 3. Over here it becomes 3q plus 4, again no common factor, therefore it is also not divisible by 3. For third one, we'll take number b x plus 4. हमने क्या लिया, number b x plus 4, and x n plus, sorry, not x, this is n plus 4. N plus 4 will be equals to 3q plus 4, or n plus 4 will be equals to 3q plus 1 plus 4, or n plus 4 will be equals to 3q plus 2 plus 4. This is not divisible by 3 because there isn't any common factor. In this will be 3q plus 5, again not divisible by 3 because there isn't any common factor. In this one, it is 3q plus 6. We can write it as 3 common q plus 2. Therefore, it is divisible by 3 because there is common 3 in this and it can be divided by 3. Now, if you see over here, from in all three, in first one, this one is divided and this is not divisible. In second case, second equation is divisible, rest two are not. In third case, only third one is divisible, rest two are not. This states and proves that one and only one out of this, which is there over here, one and only one out of n plus 2 and n plus 4 is divisible by this. इन तीनों में से हर बारी कोई ना कोई एक डिविजिबल होगा 3 से if n is a positive integer. Okay, and over here हमने n को positive integer माना है, एक बारी n एक बार n plus 4 लिया और it is divisible by 3. This ends with your first chapter. Now you will have to do this in your copy. I hope each and every one of you got this. If still you have any doubt, you can ask me on online class.